Greetings from the sub-ether. This is Alan with another color basic video, this time continuing the discussion on the get and put commands in extended color basic. If you look at part 1, you will see that I kind of came up with this idea of demonstrating it by drawing a box with an X over it, getting that memory into a buffer, and putting it elsewhere on the screen like a software sprite. So I took that code and kind of made this little program that lets me type in the X and Y and the width and height. Then it will jump to a routine that gets it into a buffer, it will put it on the screen with another routine, and then there's a routine that waits for a key press. So let me load this into memory and show you how it works. At 0, 0, 16, 16, it draws that box, top left corner. When I hit a key, it's going to draw it at another even byte boundary, 32, 32. When I hit the key again, it's going to try to draw it at 100, 100. And that one crashes. Let me make it bigger so you can see it. 32, 32. We're doing a normal get without the dash, the comma G option. 32, 32. And then at 100, 100, it crashes. It seems that if you put anything and it's not on an even byte boundary, you need to add PSET. But if it's on an even byte boundary, you don't need comma G, and you don't need comma PSET unless you're doing some kind of special math with and or. You don't need anything after your variable. So now if I run it, 0, 0, 32, 32, that's just how big and we're starting. Even boundary, not an even byte. So the things we've learned here is when you go to get something, and here is my line for that, you don't need comma G if the object you're getting falls on an even byte boundary, and when you're putting it on the screen, if you're putting it on an even byte boundary, you don't need PSET. So you need comma PSET with the put if it's going to go on a non-even boundary. Let me get rid of that again. Now this time we're going to do the same test, but we're going to put it at 1, 0. So it'll be 1 pixel over, so it will not be on an even byte boundary. Immediately we can't even get. So now we know the rules. Comma G if you're getting something that's not on an even byte boundary. Comma PSET if you're not putting something on an even byte boundary. But if you move all your graphics 8 pixels at a time on this P Mode 4 screen, and you never try to put them in between, so if your smooth scrolling is 8 pixels at a time, you don't need comma PSET, you don't need comma G. But since I want to do that, I put comma G to get it, 1, 0, 32, 32. I can get it, put it at 32, 32, and we still crash because I took PSET off. So comma G is I'm getting it from individual bytes inside of bits inside of a byte. It's going to be offset. And comma PSET is I'm putting it on a non-byte boundary. So if I have comma G right up here, comma PSET on the put, and I run it, I should be able to get it from any position and put it on a even byte or an odd byte boundary without any problem. So that's the rule that I figured out with get and put. If you do everything on a byte aligned, you don't need anything special. If you're going to put non-byte aligned, you put comma PSET. If you're going to get non-byte aligned, you're going to need comma G. But wait, there's more. I'm going to put this back, get rid of the PSET, and I'm going to go to my get and get rid of the comma G so it can only get on a byte boundary. And I'm going to do 0, 0, 30, 30. Well, that worked as we expected. Get doesn't seem to care about the width of the object. Let's try it again. How about 7, 7? That's clearly not as wide as a byte. Still works. Now we're getting the error in line 2010 because it is trying to put it on a non-even boundary. But without the G, it doesn't look like we care about the width. I can go 0, 0 and say 21, 21. Well, maybe I can't. What's going on with 1, 1, 1, 0? Just a normal get. X and Y is 0. Width and height is 21, 21. So what are the rules with getting? We know that if I always do multiples of bytes, that works fine. We know that there we go. We know that some values, 9 comma 9, no. 8 comma 8, yeah, even byte. 21 21, no. 16 16, even bytes, that works. 31 31. Well, that's interesting. So there's something going on here when you are getting data that's not evenly aligned. It's just going to have problems. Some values seem to work. Some values don't work at all. And as you can see right now, some values are all screwed up. Now again, if I put -G here and run that same example, 31 31, everything's fine. -G lets it get things whether they're on an even or odd boundary. But look, 0 0 is an even boundary. Get rid of the -G and run that again, 0 0, 31 31. So it's not just that it has to start on an even boundary. Apparently, it needs to be an even number of pixels. But not all pixels behave this way. Now, if I were to say 1 comma 0, 31 comma 31, same thing. But I didn't get it on an even byte boundary. And there's no comma G. So comma G does not mean it has to start on a byte boundary. Or rather, you can get something even if it's not on a byte boundary without using comma G. 1 comma 0, 32 comma 32, that won't work. 1 comma 0, 31 comma 32, it does work. Why? Because we're starting at pixel 1 and going all the way over to the 32nd pixel. But when you put it, that's when it has problems. And you could probably decode what this is doing. It's drawing a horizontal line, then it's supposed to have a line down one side and a line down the other. This is the diagonal line. We could probably actually look at these pixels and reverse what it's actually doing as it blasts across the screen the data. But we're going to correct our understanding. Comma G does not mean it has to be byte aligned. But there is a rule that if you're going to put it on the screen, in fact, let's just try that. Let's put comma PSET. Oh, there's already comma PSET there. Okay, 1 comma 0, 31 31. The PSET tries to do it, but it doesn't match. So I believe in most cases they would match. You'd do comma G, comma PSET. But there's a lot more going on than what I initially thought. So let's see if we can fix this. If we put comma G, then we can go 1 comma 0, 31 comma 31, and it just doesn't care. In fact, when you do comma G, we can say 3 comma 0, and let's do 7 comma 7. Doesn't care. So I want to define what the rules are with get and put and create a little tutorial that finally explains what each step does. But I thought I'd demonstrate this to you and show you it's not quite as simple as I initially thought. 0 0, 32 32, that works. And you can get it and put it on even boundaries without comma G and without comma PSET. But as soon as you want to put it on an odd pixel boundary, something that's not a byte, you have to use comma PSET. And as soon as you get it from a non-pixel or non-byte pixel, you have to comma G to get it. But you also have to use comma G in other situations if the width is also not on a pixel byte boundary. So there's more to this discussion. We're going to have to look at how this data is stored on the screen, and I bet we can figure it out. So until next time, don't panic.